Good morning and good afternoon. Today, we welcome you to the event Virtualized Applications in Digital Substations. Today, I'm here with my colleague Jan Hille, who is Solution Architect at Welotec, and myself, Managing Director and CTO at Welotec. We want to talk for around about 30 minutes about the possibilities of having applications running on a virtualized machine instead of single appliances. At the end of this session, we'll have some time for questions. Please feel free to ask questions at any time over the chat. So today we talk about the possibility of virtualization and why we need it now. So virtualization in data centers is a proven concept for many years, and it's used and very major already. But in substations, it's not used yet. So if you virtualize applications, you get a lot of advantages. And so the question is, why not before? And the reason behind is that now fast enough servers are available that are able to meet the harsh requirements in substations, like IEEE 61850-3 or IEEE 1613, the high EMC levels, temperature fluctuations, and so on. So what kind of applications can be virtualized in substations? So the issue that many energy companies have is that they have a lot of appliances inside, like a firewall, like a substation automation system, HMI, and for example, PQ analyzers. Besides that, more and more applications and appliances will be added. So again, more boxes, like intrusion detection system for increasing cybersecurity levels, or log server or physical cybersecurity like video surveillance, and more. So this brings some trouble to the operators of substations because they need to integrate more and more hardware, they need to maintain more and more hardware, and they need to look at it. So the idea about virtualization is separating the hardware and the software. And so we get some kind of software-defined substation automation and substation security system. This includes that bare metal installations, boxes like firewall, intrusion detection system, any SAS system or SAS gateway, fault recorder, HMI, and power quality analysis can be virtualized on one or several redundant computer or server systems. This will dramatically reduce operating cost, and not only operating cost OPEX, but also CAPEX, or capital investment cost. It will also increase the reliability and the cybersecurity and make it more flexible and long-term available for the future. Jan, now it's your turn. Please talk a little bit about the basics of virtualization.
Yes, thank you very much, Jos. Hello to everybody. Let's now take a closer look into virtualization, what it is and how it actually works. In general, you can say virtualization is the process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. But what does that mean? If you take a look on the left picture, you see like a classical computer system. You have some hardware, some CPU, memory, a disk, some interfaces like a network interface. You install an operating system like Windows, and inside this operating system, you install your applications. This might be a computer like you are sitting in front of right now. You are running probably a Windows operating system and the Zoom meeting app, which you're now using to join this meeting. But this could only be also be, for example, an HMI in a substation, or the whole system could be a gateway or a firewall or a log server. If you take now a look at the right picture, you see we added a virtualization layer there, which is called a hypervisor. What this hypervisor is doing, it takes the resources like the CPU, RAM, disk, network, and also other interfaces like USB or serial interfaces, and manages these resources for the machines running on it. What we can do now we can build multiple computers inside this virtualization layer, which look like physical computers. We can install an operating system again, install applications inside there again, and we can run several of these computer systems at the same time within this virtualization layer, within this hypervisor. Now, we need a closer look onto the hypervisors. There are mainly two different types of hypervisors. Type 1 hypervisors, which are also called bare metal hypervisors, and type 2 hypervisors, which we call hosted hypervisor. The main difference between those two is that type 1 hypervisors are directly installed on the hardware, are installed like an operating system. They have direct access to the hardware and to all the other system resources. While type 2 hypervisors or hosted hypervisors are installed as an application on top of the host operating system. So you install, for example, a Windows operating system, and then you install some application, which then is taking care of managing and coordinating access to the resources like CPU, RAM, and interfaces. Examples for the hypervisors, for the type 1 hypervisors, would be, for example, Microsoft's Hyper-V, which is even a role in the most common Windows Server operating system, in the actual server operating systems from Microsoft, or, for example, VMware ESXi. Type 2 hypervisors, they can also be installed on simple computers like the one you are sitting in front of right now, which would be, for example, VMware Workstation Player or VirtualBox, or, for example, a Parallels hypervisor. Type 1 hypervisors are best suited for substation automation because they are most performant, because they have direct access to the hardware, and also they don't have such a big attack surface. They are more secure because they are not relying on a separate operating system, which might have some vulnerabilities which can be exploited. We have, of course, possibilities to manage these hypervisors and the virtual machines. All the solutions have in common that they have possibilities for local management and also for some central management of virtual machines and of the host systems. The two different hypervisors we've been talking about previously, Microsoft Hyper-V and VMware ESXi, follow some different design principles, leading to the fact that the VMware ESXi does not have a pretty interface which you can use directly at the hypervisor. You will most probably access the hypervisor and the management with a web browser through a management Ethernet port on the host system, while the Microsoft Hyper-V hypervisor looks and feels like a hosted hypervisor. So you have to install a Microsoft Server operating system, and then you add the role of Hyper-V, meaning that you have a pretty well-known environment there. You start the server, you have the operating system, you have an icon where you can start the hypervisor with, and you see it's the top right picture. You have an application where you can manage all your virtual computers and everything else. What they have all in common, they have different possibilities to manage a virtual computer in first step, like a classic physical computer. What does it mean? You can like assemble a computer. You take some CPU cores, you take some RAM, you take some interfaces, you assemble that all, you start the machine, you can mount a DVD or an ISO file where you can load the operating system from, and then you can install it into the machine. And then again, you have an interface like a virtual display. You have keyboard and mouse support on the host system. You install your applications right away, like you have a classical computer. It looks and feels like a classical computer. But the benefits of virtualization come when you take a look at the management, which goes beyond the management of a classic computer. Could you please go back to the, thank you. what we can do there, we can, for example, take snapshots of these virtual computers. What does it mean? A snapshot is like a photograph of the current state of the virtual machine and the application running inside there. What could it be used for? For example, if you have to install some minor updates of the operating system of the virtual machine or some service pack, you just take a snapshot. You install the service pack, you check if everything runs as desired. And in case of problems, you just revert the computer state to the snapshot state. It's like you have never done any change to the machine at all. What we can also do, we can also duplicate, so it's like a copy or import and export virtual computers. This gets very interesting in case you have some very big changes on a device which requires some testing and would require some downtime of the system. What you can do then, you can duplicate this computer and isolate it and do the changes, or even export the whole environment consisting of several machines to some lab testing hypervisor environment, which might be on your desk or in your lab. Then you do all the changes, test the interoperability, how the whole system behaves. And if everything works as expected, you just import the changed machines back to the operational system. You stop the previous system, you enable the newly imported system to take over operation, and you reduce the downtime pretty much to zero or to an absolute minimum. What's also pretty interesting, we have some networking management possibilities in the virtual environment. You can consider this virtual environment like a rack of like you know it now, with several boxes, and you may have switches inside this rack. These switches can be used to attach virtual machines to each other, or virtual machines to the outside interfaces, the physical interfaces of the host system. Meaning that the traffic that is between the virtual machines will never leave the hypervisor system. It will stay inside the virtualized solution and will not cause any load on the substation network, and also will not be visible in the substation network, meaning it's a small attack surface there. What's also possible, we at Welotec already proved that it's possible to even secure the traffic between the virtual machines and the host operating system and the outside world by adding a virtual firewall appliance, which takes care of all the traffic which is inside the virtual environment and which leaves the host system or gets inside there. Okay. What we can also do, this was all management options which are locally available at each single host, but you will probably have at least a redundant system, most probably even a multiple redundant systems in different substations. What we can do, we can add some central management solution, giving us all the possibilities which I described just before, and adding some extra benefit to this solution. We have some central monitoring of all the virtual computers health state, also some central monitoring of the virtualization host system, meaning we could have the central management solution, for example, in the SCADA system, where it's, we just need some kind of network connection to the management of the host system, and we can notify the operator in case of anything happens in this virtual system. For example, if a host has some power failure or something like that. We can also have notifications for the IT department by email or on any other communication gateway, meaning that we really increase the availability and the hostability of the system by that. What's another interesting point? We said before we can copy or import or export virtual machines. With the central management, we can also implement some real backup solutions, which take care of scheduled backup and backup management. We can, for example, say, please back up all my virtual machines. So all the appliances, the HMI, the gateway, the log server, please back up those machines every night at, for example, at 1 a.m. And please keep 7 weekly backups, 7 daily backups, 1 yearly backup. So we have a real backup management and backup history. One other important point, we can set up some kind of high availability in this whole solution. High availability means that we have a managed solution which takes care of the operation of the virtual machines. So all the HMIs, gateways, log servers, engineering workstations, they monitor the state of the host system. And in case of trouble in the host system, it is possible to set up a solution which enables another host system to automatically take over the virtual machines of the host system, which might get in trouble because of a power failure or things like that. Will increase availability and durability of the system dramatically, and will give much more security to the host system. Okay, now back to Jos. He will tell you something about virtualized appliances.
Cool. Thank you very much, Jan. So if we are in a substation, we have a lot of appliances there, as mentioned at the beginning. Looking especially at the station level, where solutions are ready today, you can virtualize, for example, the full OT and IT security that you have in a substation. This would include that you set up a virtual server for firewall, for intrusion detection system, for additional log server, and probably any other physical intrusion detection system like video surveillance. And this can run in the substation on one standardized hardware. So you don't have 5 different boxes from 5 different vendors, but only one hardware and just utilize the software on it. But from another perspective, you can also virtualize all the OT systems, like the substation gateway, substation automation system, the power quality analysis, the engineering workstation, and so on. And this can also be run on a separate device. So you can have your OT department managing those applications, your IT security or OT security department managing the firewall, and so on. So you would have 2 types of virtualization hosts, one for the OT and one for the IT security. But you can also combine them. So by having them on separate devices. So you just set up a stack of server instead of having all those boxes. Have your perfect redundancy. You have some kind of free resources in case something fails. The virtual machines are just switched and moved to another hardware platform, which will be seamless without any big interference. But this is not the end. So before we talked about the station level that you can virtualize today. But if you're looking on the process level where you have the primary equipment, it can directly interface with computers. So you don't need any bay level anymore where you have your IEDs. You can run them as a virtual machine on the devices. The requirement for that is that you have real-time hypervisors. So at the moment we are working on also realizing real-time operating system, real-time hypervisors to also virtualize safety relevant applications like protection and control. So at the end, you have software-defined protection and control instead of protection and control that is really hardware-based. And this is a very big advantage because it can reduce the operating cost and also the capital cost, so OPEX and CAPEX, tremendously. I heard from others that by doing this, you can reduce the OPEX by nearly 70%, which is a very big reduction, especially if you just use technology that's already available. So perfect. Thank you very much. This was the introduction of the short session today. Now we are open to question and answers. We have Thomas with us.
Hello.
Who will check what kind of questions we have and ask them. Before we go to Thomas, I just want to highlight that we also have some kind of webinars in November planned. There will be one about virtualized security together with Fortinet. And we'll have one about HSR and PRP and using that in a virtualized environment together with SOCI. These events, you'll get an invitation to that as soon as, again, and everything is finally fixed. Thomas, now, do we have any questions?
Good morning and good afternoon to everyone. We got a couple of questions. Most are for Jan, I think, and one for Jos. Let's start with the one for Jos. Sarah would like to know that you mentioned CAPEX and OPEX savings, but virtualization needs more powerful computer systems. Can you tell us something about where the savings are coming from?
Sure. Of course, you need more powerful computer systems, but if you have just a few computers, it's always a reduction compared to many systems. So if you are looking at, for example, 5 boxes that can be virtualized on one device, and if you want to have it redundant on 2 devices instead of 5 or 10. So there is definitely a CAPEX reduction. And if you're looking on the OPEX reduction, imagine what happens if you have 5 different devices in a substation, so hardware devices. So you need to maintain this hardware. You need to make sure that you have spares. In case one hardware fails, you need to physically replace it right away. So with virtualization, you can just do that virtually. So you just move one snapshot, so one, for example, firewall, from one computer to the other.
Okay. We have a question for Jan, I think, from Andri. I hope I didn't mangle your name too badly. We have a question regarding preparing technical orders on building stage, on the bidding stage for a project for digital substations. Could you advise something? What might be the requirements? Any advices for preparing preliminary specifications, etc.?
Well, this highly depends, of course, on your application needs. If I get the question correctly, what we can do, we can take a look at the boxes you now have, what the needed resources are, and based on that, we can for sure build a pretty good setup, which will cover all the needs you need, plus a little bit of spare. I hope I got the question correctly. If not, please come back to us after the meeting. We can discuss it afterwards as well.
Okay, thank you very much. Alex would like to know how long is the failover time if a hardware host fails?
In a redundant system with high availability, if you configure the high availability properly, you will not see any downtime, because the virtual machines are taking over right away as soon as the host system is going down. There are some watchdogs inside there. The host system, the high availability system takes care about the whole host system environment, and it will enable another host to take the virtual machines of a host system as soon as it gets down. So there might be a downtime of for example, a few seconds, but not a real downtime like you know it if you have to exchange some hardware box.
Okay, thank you. I'm not sure if this is best suited for Jos or Jan, but Kenneth would like to know, please explain the removal of bay level.
Okay, I think I will take this one. So it's not really a removal of the bay level. It's just taking standard computer hardware, which is using a real-time hypervisor and adding the IEDs there. So you can virtualize the functionality of the IEDs and have some kind of software-defined protection and control. This means that you don't need the physical IEDs with their functionality anymore, but can just run them as software. I mean, they are more or less some kind of computer already. And this type of computer is just running some real-time operating system and the functionality on top of it. And the same you can do with virtualization if you use a real-time hypervisor. There is a real-time hypervisor, for example, from Wind River, which is called Heliox platform. There is also another hypervisor from Intel, which is open source and can be used for this. And then you can run, for example, VxWorks on top of it and your functionality on top. Of course, you need to wait until the vendors are ready and deliver also the virtual machines for that and create this kind of ability for you.
Okay, next question is from Abdel Aziz. How can you manage redundancy with reducing the number of boxes? I think this one is for Jan.
You may already have a redundant setup in your substation, meaning you have, for example, 6 boxes, an HMI, a gateway, log server, substation automation system. And the easiest way you have now is you have 2 of each. This is pretty much the easiest way in a virtual environment as well, meaning you have those 5 or 6 boxes, you virtualize these boxes and put it on one substation automation server, on one RSAPC. If you need a redundant system, you have another RSAPC with the same setup, meaning it's a classical redundancy from the OT perspective. Just another machine takes over the operation of the other one. So we'll have the reduction of 5 on 1, and this is 2 times. The other thing is if we are talking about a real high availability system, then we'll be able to also decrease the number of the substation servers we need in there, because we do not need to copy the system one by one, because other servers will be able to take over the operation of the virtual machines in case of a host system failure. So easiest way, we virtualize everything. You have 5 boxes, then you only have 1, or you have 10 boxes, then you only have 2. The more complex way is taking a high availability system where we can reduce even more.
Okay, Nitin has 3 questions, I think. One I can answer: communication on RJ45 or fiber optical. Both is possible depending on the interfaces you add to the system. And the second one would be how to connect the current voltage field interface modules from the field. Any one of you have an idea about that?
Yes, or Jan, you want to do that?
Yeah, Jos, you may.
Okay. Of course, what you need is you need to have a digital substation. This means you need to digitalize the signals, so you cannot just connect copper signals. So you need to convert it to Ethernet, which can be done, for example, by merging unit or by a non-conventional transformer, where you have some kind of Ethernet interface and bring the non-digital signal in a digital world directly as a primary equipment. As soon as you have done this, you can use the Ethernet network and transfer the signal and use IEEE 61850 protocols to do that.
Okay, the last question from Nitin: does the module communicate with IEEE 61850-9-2? Who's taking it?
I hope I got it right. I think you're talking about PTP and time synchronization. So in the station level, we don't need time synchronization that is that accurate for the applications. At the moment, it's not available there as well. So if you have a grandmaster clock, you can bring the signal to the server, and there we can bring it just with standard mechanisms to Windows or Linux. Of course, if you're going to the Bay level, you need to have PTP timestamping, and there you need to add some kind of real-time hardware. We have a RSAPC card, which is optional for the equipment, which is allowing you to do the PTP timestamping. Hope that answers the question.
Thank you very much. The next one is for Jan from Satish. How many machines can be run on each RSAPC?
Yeah, again, that highly depends on the applications running on the machines. We have some, let's call it, limitations on the host system with regards to RAM and to CPU cores. We have been able in our lab to easily run 7 virtual machines on the device. What's important to know, in physical machines as well as in virtual machines, we have a big amount of idle time. So if you take a look on your computer, it does not always run on on 100% CPU and in 100% RAM. And the hypervisor system takes over the management of the resources, meaning that the virtual machine will get the resources at the time it needs the resources, meaning that we can provide more resources than we actually have or physically have in the substation server. So again, the limitation is based on the application's needs. Just as a rule of thumb, we can say we need, for example, 4 gigs of RAM for the hypervisor, and the rest meaning 60 gigs of RAM in this server will be available for the virtual machines. But yeah, again, we have been able to easily run 7 virtual machines at the same time. Depends on your application.
Thank you. Usman would like to know, and this is probably for the both of you, is there any tool where we can create virtual substations with different devices for learning purposes and understanding the system better?
Yeah, from the perspective of the hypervisors, there are evaluation versions of the hypervisors available from the big vendors. In case of VMware ESXi, there's an evaluation version downloadable on their site. In case of Microsoft Hyper-V, as I said before, it's more or less part of the operating system or a role of the operating system, meaning that you can just take an evaluation version of Microsoft Server, for example, Servers 2019, and just activate the role. What you can do then, you can, in fact, virtualize your physical appliances. There are tools for that. Or you build up new appliances. You will probably need the equipment which the machines have to communicate to. In your lab as well, because it has to be attached to the physical interfaces of the host system. As you said before, virtual IEDs are in plan, but not, it's more an outlook. Maybe Jos, you might have to add something to this.
Yeah, we work with the large vendors, and that we did those tests. So you always need the secondary equipment like IEDs to run those applications and to check everything. You also need the software license. So if you want to have a firewall, you need a license from Fortinet, for example. If you want to have IDS, you probably need a license, for example, from our partner Radiflow or Nozomi. And if you want to run anything else, you need that type of software that you want to run there, and then you can test everything. Usually you will get trial licenses for that.
Okay, we're already running a bit over time, and we have a lot more questions than we get to. For everyone in the webinar that still have questions, you can dump them into the chat and we will follow up via email later. But I think we still have time to answer 1 question or possibly 2 questions. This one, I guess, is for Jos from Juan. Is there a standard for substations like ETSI standard for telecom NFVs?
I'm not sure if I fully understand the question. So there is a standard for substations, but there is IEEE 61850. And this standard is describing the communication and also the requirement for the environment, like EMC levels and temperatures. So this is available for substations, but it does not describe how to run the applications if you need bare metal or virtualized applications.
Okay, and I guess one last question from Tushar, maybe for both. Do you recommend virtualization in SAS, as it is a very small system which does not require multiple application servers?
Maybe I answer that. SAS is substation automation system. So if you have a substation automation system, even if it's very small and with not many resources needed, but you also have to add the firewall to meet the IT security levels. You need probably engineering workstation that is there. So you can virtualize multiple applications on one host. Besides that, there's also advantage in running virtualized applications only if you have one application. And the advantage is that you can take snapshots. And if you need to do some upgrade, you are not in the risk of crashing the system. You just upgrade the system. If something is not working, you restart your recovery and everything is fine. So this is also another advantage from virtual machines.
Thank you. And very last, because it closes down the webinar quite nicely, from Yusuf. Is there any way I could get a recording of the webinar, and would it be possible to get context details of the presenters for follow-ups? And for closing out, I hand over to Jos again.
Great. So thank you very much. There is a recording on our YouTube channel that you can see. So we also stream the webinar live to YouTube. But what you can also get is into contact on this slide. You see my email address, and you also see the email address of Jan. So just get in contact with us, and we'll send you a recording of the webinar for you. And we can also share presentations and white papers. So just get in contact with us, and we'll send you all the requirements. If you have some colleagues that are interested in everything, we can also do some kind of more extensive sessions just for you and your colleagues if needed. Okay, perfect. Thank you very much. It was a nice show this morning or afternoon, depending where you are. And hope to see you soon in November for other sessions. Goodbye.